Okay, in this video, we're going to take a look at multiplication and division with rational expressions. So the thing to remember when we're talking about rational expressions, we are basically talking about fractions. Okay, so we're going to follow the same multiplication and division rules for rational expressions as we do for fractions. And we're just going to review those here first. This first one is for multiplication. And you can see if you have two fractions, a over b times c over d, all you do is multiply straight across the top, multiply the two numerators, and you get a times c. You multiply straight across the bottom, multiply by the two denominators, and you get b times d. That's how we do fraction multiplication. Pretty basic. Fraction division is a little different. So they wrote this here as a nice, giant, big, complex fraction. This would be equivalent to writing a over b divided by c over d. That would be another way to write out that problem. But anytime we are dividing by fractions, you may have heard this phrase before. What we're actually going to do is multiply by the reciprocal. Bunch of crazy math words there. Multiply, we all know how to multiply. The reciprocal, what we're saying there is we take the second fraction, either second if it's written like this, or the one on the bottom if it's written like this. We flip it upside down, that is the reciprocal, and we multiply those two new fractions together. One of my students once used to call it skip, flip, and multiply. Because you skip that first fraction, a over b stays the same. You flip that second fraction, and then you multiply the two together. So let's practice that a little bit. First, we're just going to practice it with numbers, and then pretty quickly we will move into doing it with some rational expressions. Okay, for this first one, I'm going to show you two different ways to do this one. You can just go ahead and multiply straight across the top. 1 times 20 is 20, and 5 times 17 is 85. Okay, there's an answer, but it is not in least common terms. It is not reduced. So then we would have to realize that each one of those numbers is divisible by 5. It can be reduced, and it would be 4 over 17, because 20 divided by 5 is 4. 85 divided by, sorry, did I say that right? 20 divided by 5 is 4. 85 divided by 5 is 17. So there is our reduced simplified answer. Another way we could have done this problem is factor all of these numbers before we do any multiplying. So we have 1 over 5, those don't factor, but 20 can be factored as 4 times 5. And then we can cancel any common factors that we have in the top and the bottom. So this 5 cancels with that 5. Up top, we just end up with 1 times 4, which is 4. And when the 5 cancels, that's really a 1 left behind. 1 times 17 is 17. Okay, so you can either reduce at the end or reduce at the beginning. It doesn't matter. We get the same answer. Number 2, we have a fraction times a whole number. So what we need to remember here, that anytime we have a whole number, it can be written as a fraction. It's just that whole number over 1. So here we have 4 times 3 for our numerator. That's 12. And 7 times 1 for our denominator, that is 7. And it's okay just to leave that as an improper fraction. We don't need to write it as a mixed number. For number 3, we have our first example of a division problem. So if we want to rewrite that, skip that first fraction, flip the second fraction, and multiply the two together. So we change that to a multiplication. And this is another example, like number 1, where we could simplify now or at the end. If we want to simplify now, we could rewrite 21 as 3 times 7, and we could rewrite 20 as 4 times 5. And then you can see we get some nice canceling going on. The 7s cancel each other out. The 4s cancel each other out. What we're left with then up top is just the 3. And on the bottom is just the 5, so 3/5 would be our answer. The other way we could have done that one is 4 times 21 is 84. That would be our numerator. And 7 times 20 is 140. That would be our denominator. And then we'd have to figure out how to reduce that. A lot of calculators will reduce fractions for you, so maybe that's easier. That reduces to 3/5. Either method is fine. Number 4, we have a division problem again. So when we rewrite that, if we skip the first and then flip the second, well, what is 9 when we flip it? Well, remember 9 is equivalent to 9 over 1. So when we flip it, it becomes 1 over 9. And then we multiply those two together. Again, here, same as the others, you can either reduce now or reduce later. 3 times 1 is 3. 4 times 9 is 36. And 3 over 36 does reduce. That's equivalent to 1 over 12. Okay, number 5, we move into rational expressions, okay? Now, right now, this is written as 2 separate fractions, but remember, for the multiplication of fractions, we just multiply the 2 tops together and we multiply the 2 bottoms together, so you can visualize that just as one giant fraction already. And when we do, we can see that there's a common factor on the top and on the bottom. So that means that this one reduces to 2x minus 1 over x plus 5. That would be our simplified answer. Now in number 6, before we start doing what we did in number 5, we need to factor. It looks like the numerator of that first fraction can be factored. That is the difference of 2 squares. So y minus 2 times y plus 2. What about the denominator? Can that be factored? Well, yeah, there's a GCF. We can pull out a 7. And this second fraction cannot be factored, so we just take a look at it from there. Remember, everything across the top is just multiplied together. Everything across the bottom is just multiplied together, so we can start canceling the y minus 2s, the y plus 5s, and what's left behind is a y plus 2 in the numerator and a 7 in the denominator. Okay, these can get to be a little more work when we have to start doing a lot of factoring, but that's okay, we're up for the challenge. Okay, notice number 7, all kinds of factoring that we can do there, and it's a division, so we are actually going to end up writing the reciprocal of this second fraction when we rewrite it. So let's just start factoring away. X squared plus 2x minus 8, well, that factors into x times x. 8 could be 2 times 4 or 1 times 8. But I need a 2 for my middle term. So to get a positive 2, that's a minus 2 and a plus 4. Factor that denominator in the same method. X times x. 3 can only be 3 times 1, so that's easy. And to get a positive 4 in the middle, they would both have to be positive. Now this is division. I'm going to change it to multiplication, and that means I have to flip this upside down. So the x minus 2 now goes on the bottom. And 3x plus 3 goes on the top, but I'm going to factor that when I write it down. That's 3 times x plus 1. And that's when the fun part comes, once you have everything factored and you have a multiplication problem. Cancel any common factors you see. I think that looks good. What do you think? So that means we are left with 3 times x plus 4 on the top and x plus 3 on the bottom. There is our simplified answer. Okay, next up, number 8. This time we have a multiplication problem. So we don't have to do any flipping, but we sure have a lot of factoring to do. Let's see what we can do here. So the first numerator, that's going to be x times x. And 35, how about 5 times 7? To get that negative 2 in the middle, we need a minus 7 and a plus 5. And then the denominator, we're looking for a product of negative 56. So 56 is 8 times 7. To get that plus x in the middle, we would need a plus 8 and a minus 7 times. Now we're ready to factor that second one. We don't flip it because this is multiplication. 24, that gives factors that give me 24 and add them up and they give me a 5. So how about an 8 times 3 gives me 24. And a plus 8 and a minus 3 gives me 5. And then finally, factor that second denominator, x. 40 is 8 times 5. That works. That gives me 13. 8 plus 5. There we go. Okay, if this factoring is going too quickly for you, you might need to go back to one of the videos on factoring and review that. We are assuming when we get to this point that we do know how to factor. Okay, but go ahead and practice that if you still needed a little brushing up. Now comes the fun part. There's an x minus 7 and an x minus 7. There's an x plus 8 and an x plus 8. There's an x plus 5 and an x plus 5. So what's left behind is an x minus 3 on the top and an x plus 8 on the bottom. Notice I canceled one of the x plus 8s, but I couldn't cancel both of them. To cancel the second x plus 8 factor, I would have needed a second one on the top too. So that's why that x plus 8 still stays behind. Okay, number 9. Well, number 9 is all factored for us already. That looks nice. So let's take a look and see what we would need to do to cancel things. Well, let's write it out, okay? N minus 3 quantity squared. Well, that's the same as n minus 3 times n minus 3, right? There's really two of those factors, and that's over n plus 5. Multiplication, so I'm not flipping anything. And then this second fraction here, the second rational expression, is n plus 5 squared, which is really n plus 5 times n plus 5. When we write it like that, you might be able to see a little more easily what cancels. One of these n minus 3s cancels there, and one of these n plus 5s cancels there. So we are left behind with no denominator. Well, the denominator is 1. Oops, I said 1 and I wrote 1. Okay, so we are left behind with n minus 3 on the top and n plus 5 on the top and nothing on the bottom, which we could write it over 1, but we don't need to because that just means our answer is n minus 3, n plus 5. Okay, more factoring on this one, number 10. Okay, let's take a look to factor that first one. I'm going to put it up here so it's kind of out of the way. 4 times 18 is, it's in a negative 18, so that'd be a negative 72. Sometimes writing and talking at the same time can be tricky. Negative 72, there we go. And our inner product, our middle term, is a negative 1. So 72 would be 8 times 9. To get a negative 1, I mean a minus 9 and a plus 8. So if we want to write that out, 4x squared plus 8x minus 9x minus 18. Factor by grouping, we can pull out a 4x. And we can pull out a negative 9. So that means that first numerator is going to factor into x plus 2 times 4x minus 9. It's going to take me a lot of space to factor. I'm actually just going to give it to you here. I'm going to make a little space for us here. So the numerator we just did, that's x plus 2, 4x minus 9. The denominator, let's do that in green over here. 3 times 4 is negative 12. Negative 4 in the middle. So a product of negative 12 and a sum of negative 4 would be 6 times 2 with a minus and a plus. You would go ahead and write it out and do your factoring by grouping. I'm going to skip that part. You guys know how to do that by now. This would be 3x plus 2 and x minus 2. Okay, and that is going to be multiplied by, can we do any factoring in this second fraction? 3x plus 2, no, that doesn't have any common factors. And 4x minus 9, no GCF there either, so we just have to leave those. Now that we have it all written out, we can see what's going on here. We get a 3x plus 2 that cancels, a 4x minus 9 that cancels, and our final answer would be an x plus 2 on the top and an x minus 2 on the bottom. There is our simplified, reduced rational expression. And we got a couple division problems up next. Those are good to practice also. Okay, number 11. Notice right here, division. So this time as we factor, we're going to flip that second fraction. So our first fraction here, you guys recognize this is a special factoring formula on the top. That is the difference of two squares. So we get 5a minus 3 and 5a plus 3. The bottom is also a difference of two squares. Division, so that means we're going to multiply by the reciprocal. A minus 2 ends up top in the numerator, and 5a minus 3 ends up in the denominator. Hopefully you can tell that's multiply, not subtract. Okay, now that we have everything factored out, anything that occurs both in the top and the bottom, like this a minus 2 can be canceled. 5a minus 3 also canceled, and we end up with 5a plus 3 over a plus 2. Okay, number 12. Another division problem. This is where we have to remember, we mentioned this before, that when you see t minus 5 as your second rational expression here, that's really t minus 5 over 1. That's important because when we go to divide, we're going to do the reciprocal or the flip. So let's start rewriting, start by factoring that numerator. T squared minus 4t minus 5. T squared is t times t. 5 can only be 5 times 1. And to get that negative 4 in the middle, we would need a minus and a plus. Factor that denominator, t times t. 6 could be 2 times 3 or 1 times 6. But to get the 7, we would need a 1 and a 6, both positive. Multiply by the reciprocal, so now the 1's on top, and the t minus 5 is on the bottom. And again, we can do some canceling. The t minus 5, the t plus 1. Be careful here. All that's left behind is t plus 6, but notice it is in the denominator. 1 is still in the numerator. So do not write the answer as t plus 6. The answer is 1 over t plus 6. That little guy cannot jump out of the denominator, okay? He's got to stay in the denominator. So that 1, when everything cancels, you still have a 1 as a placeholder there. Okay, a couple more. This next one, number 13, we need to do some factoring. And how about this? Anybody remember what kind of factoring happens for that? Z cubed minus 1. Well, that's a formula we don't see quite as often. That is the difference of two cubes, okay? So in this case, we have a cubed minus b cubed, and we have a formula for that. So in this case, a would be z, and b would be 1. And the formula for the difference of two cubes is a minus b times a squared plus ab plus b squared. So there is our factorization in the difference of two cubes. On the bottom, oh, look at that. Now we have the sum of two cubes. So we have the same a and b, but the formula is just a little bit different. It's a plus b times a squared minus ab plus b squared. So there's our first rational expression factored, times, we need to do some factoring here too. The top is going to factor into z times z, and 1 times 1. Oh, wait. There is no way to add 1 plus 1 and get a middle term of negative z. So it turns out that that doesn't actually factor at all. I'm going to have to erase that. And since it doesn't factor, we just copy it down as it was. The bottom does factor though. That's the difference of two squares. Lots of z's and 1's in this one. So now we take a look carefully. Oh, you know what? I couldn't see it. I circled that z. Let me erase this. Look at that. It was a plus there. That's a plus. I copied it down wrong. Okay, so now we look for our common factors. We get a z minus 1 and a z minus 1. And this whole expression here, z squared minus z plus 1, factors with this whole thing here. And it looks like what we're left behind with up top, we have that z squared plus z plus 1 over z plus 1. Oh, look, it's a z plus 1 and a z plus 1. So if we want to be fancy, we can write that as z plus 1 quantity squared. There's our simplified answer. Okay, number 14. So this one is written a little differently than the ones we've seen so far. This is still a division of two fractions, but it's written as what we call a complex fraction. So it really is same as division. This is our numerator, so it's going to be that fraction divided by this fraction. Okay, so if we wanted to, we could write this as 14x over x squared minus 36 divided by 12x. Notice I haven't flipped anything. I'm just copying it down. That's another way to write the exact same problem. Okay, so since we are dividing two fractions, we want to copy down the first one, and we'll go ahead and factor anything that we can. So that denominator becomes x plus 6 and x minus 6. And then we multiply by the reciprocal of the second one. No factoring there. So let's take a look. Those x plus 6's cancel. Let me get my red. Why isn't it red? There we go. What else cancels? Well, we have 14 times x and 12 times x, so those x's cancel each other. And then notice anything else? 14 and 12 both share a common factor of 2. So 14 divided by 2 is 7. 12 divided by 2 is 6. So what's left behind then is 7 over 6 times x minus 6. There is our simplified answer. Okay, we got a few more on this one. I'm going to skip the next 3. You guys can try those on your own for fun if you want. And I'm going to go ahead and go to this last little sort of word problem here. It says fill in the shaded area with a binomial or trinomial. So that means something that has 2 or 3 terms to make the statement true. Okay, so we have to fill in some expression. It's going to have some x's in it in that box to make this a true statement. So think about this. If we had, let's see, 6 divided by 2. Just think about numbers for a minute. And we were to reduce that or do the division. 6 divided by 2 is 3. So if we were to work in reverse, notice that 3 times 2 is 6, right? So what goes in this box here is going to have to be this expression times this expression in order to make this equivalent. So what we end up with is x plus 3 and x plus 8 multiplied together. Since it asks for a binomial or a trinomial, we need to go ahead and multiply this out. So you can distribute or FOIL, however you like to think of your multiplying. X times x is x squared. And then we get an x times 8, which is 8x. And we get a 3 times x. And we get a 3 times 8. So it's going to end up being a trinomial. The trinomial, combine those two like terms, the trinomial that would need to go into that box to make that a true statement would be x squared plus 11x plus 24. And that's it for this video.